Well, hey, what do you know? Yeah, I decided to make another musings before. I mean, I ate something, but like, I decided to make another musings before I do the code video because I thought it'd be an interesting, or I thought it'd be useful to talk about um, the Sudoku video that I did with the microphone muted. That's also why, like, I don't know, usually I'll do just like a quick little video, make sure that the whatever headset I'm using, my sons or my daughters or mine, like whatever's plugged in at the moment. And honestly, real quick, for IT, that is one of the biggest issues or perpetrators of tech issues is or well, no, it's just one of the biggest. Yeah. So when you switch networks, when you switch like setups, when you have, oh, look at that, it's all dry because we haven't had it loaded in long enough. Yes. A village. Yeah, hello. Actually, I don't know if I even want anything from here. I don't care. Even if they have like diamonds or something, I feel like we can mine our own. The camel, though, and I have a saddle. That is something I want to try to do. So, anyways, yeah. So I recorded a video, and that's the other thing with the coding videos too. I want to try to keep them to like half an hour. Oh yeah. Oh yeah. All right, we're gonna ride a camel in the desert. Sorry, I just totally jacked this camel from this village. So okay, I did want to steal something. Yep, exactly. Ah, actually, I don't know how long I want to do this. I might want to just ride it up to our base and like keep it, but like, or you know what? Can I take the um? Yes. Okay, camel. Wait. Actually, wait. Sorry, I just totally stole you from a place and I was gonna leave you out in the open. I'm so sorry. I'm such a bad person. There's a camel right next to our base. So, and I don't even have to. So this is our remote, not even really a base yet, or even an outpost, or even like a tiny little settlement. Like, I'm sorry. Here's your camel up on the hill. Okay, inventory, remove the saddle. Oh, so that's also how you do it with horses, by the way. So, oh, wait, can I do that? And then yes, awesome. So multiple ways to do it. I thought you had to dismount and then put the saddle on, but you can choose to just let the camel take you around. By the way, when my college roommate and I were in a store, the clerk asked us, uh, "Do you really have camels out there?" He's like, "Yes, my camel goes 80 miles an hour." Like without missing a beat, he just said that. It's like, "Are you kidding me?" And that dude believed him. Like, dude's like, "Wow, that's wild." Like, and he actually sat there and thought about it for a sec. Also, this is really cool. It is a pretty slow camel, so I think we can do better walking. And yes, we'll leave him in his home, or her in her home. Thanks for the ride, though. That was cool. So we learned a lot about camels just now. Um, I'm trying to think of what else is in the update, and I know they say what's in the update, and they even gave us a whole game of what's in the update. The sniffer is what we really need to. Ooh, I think sniffer eggs are part of what you get when you do archaeology. I need to just look up a YouTube of like a sniffer egg or something. That's like our next thing. That's our next goal, is to find a sniffer and start getting those plants. And then we've got the update, I feel like. I mean, mostly anyway. Oh, but anyways, the coding thing. So it was a really fun. It ended up being like an hour and yeah, an hour of no audio. So just kind of recreate it or like give the sonat or the recap. Um, it was the Sudoku solution validator, and it was demoted to an orange, which is understandable. I mean, it is kind of an easier one, um, especially in hindsight. Like when you first approach it, you're like, "Whoa, I gotta, basically play Sudoku," but not really. In fact, they do have challenges in there where you do play Sudoku, or you have to make a program that solves a Sudoku puzzle. And even that, like, so there's recursive algorithms to um, do every single combination and brute force it until they find the winning combination. And then with machine learning and artificial intelligence, you can record those patterns and those pathways. And then that's how chess is no longer like, I mean, the computer can beat the human every time. I'm pretty sure we got to that point. So like with Watson or Deep Blue or one of those chess things. But anyways, my point being is like we can teach machines to remember the things that we can't, and it takes us a while. I mean, but at the same time, we are as powerful as, or at least the information available to us is as powerful as our devices. So now, granted, say there's a huge solar flare and it all goes out, and then everything is all doom and oh, I shudder to think. And I hope that we're actually developing things that like would survive that, because even in the days of small soldiers, I know we were talking about Sudoku and now we're talking about the apocalypse, but small soldiers, if you haven't seen it, here's spoilers, but they have an EMP blast, like electromagnetic pulse that takes out all of the soldiers. So then, um, and even magnets used to do that. And I even read China had a weapon. This was in Popular Science actually. It was about China's army stuff, and like they had a bomb designed to make a blackout happen in like a so many mile radius or 1 or 2 mile, I don't know, but like, but either way, like I don't. From what I've seen with China, they're very hesitant to do anything violent, and especially you think about like World War II went off. I mean, all this stuff, and I don't remember if they were involved or not. Like I know they weren't one of the major players, but now I'm like starting to wonder, like, wait, were they? But I don't think so, because I feel like if they were, I would have heard about it. Like they might have been sympathizers, but I mean, they're very slow to anger and to violence, I should say, and they are very concerned about the Taiwan thing, and that's understandable. And like I mean, you know, the England America thing was pretty bad too, and so in no way would I want it to get that bad. And and they're out there doing military drills, trying to like threaten, but like we don't want to, and I don't know. Yeah, we all know my opinions on that. So back to the Sudoku solution validator, and not the solver, the validator. Oh, sorry, the brute force chooses every single option and then finds the solution. You can also do the problem. It's like the two queens to see like how many ways that they could be, or how many spaces on a chessboard can they both be, and not be in each other's like path of attack or whatever. And it's like you move it to each possible combination or permutation, really. And the difference between that, the combination, um, duplicate sets didn't matter. So if you order didn't matter. Sorry, that's a better way to explain it. Now with permutations, order does matter. So like, say you have a group of like circle, triangle, circle, and then you have circle, circle, triangle. Well, those would be the same if it was a combination. So you'd have the same elements in a combination of that, but a permutation would have each of those be separate. And even within that, you could, well, let's see. If it was, I mean, if it's the same item or the same number, I don't think it would be unique. Well, it's every different unique order. So, anyways, that was way off the. But the Sudoku solution validator, first you check, or at least this is how I did it. First, I checked for rows because you're being fed in um, a list of lists. And what that is it's an array of arrays or a two-dimensional array. They're all the same thing. And that is it's a list containing a bunch of like mini list objects. But I mean, there's nothing mini about them. It's actually the same, because it's 9 of them, and within each one there's 9 values, and each of those 9 values, and like, so each list is already broken up into rows basically, and it goes left to right, top to bottom. So each row is a list, and then it gives 9 lists. And so now you have to, well, at least for the rows, you just have to see if one and only one of each number exists in each list or each sub list, but it's still a list, so I don't want to get anyone confused. Like, a list is an array. For anybody who's learned Java but still doesn't, hasn't dabbled with Python, it is just an array. Although I want to say it's an array list, because array lists are the ones that are dynamically adjustable. So if they fill up, they'll recreate themselves with more memory allocated. And that's just like, yeah, dynamic memory allocation, which is very handy. But also why Java has some overhead. Now with C++, you do that, and you just start running over whatever other data is above that, and sometimes even without bounds. So if you're not checking for that, that is part of a software security vulnerability. So I'm actually telling you, you should make sure that you allot or allocate exactly what you need every time, and account for when things can go haywire, like if it can be manipulated. And most software developers know this. I mean, I was actually taught this just for my degree, so that was before the cybersecurity awareness, and that's why I wasn't so aware of like the passwords for emails and stuff. And all that was is like, I just can't use an iPad now. Like, whoop-de-doo. I mean, I have all my accounts secured with multi-factor authentication, like even down to like accounts that I don't use. I set it up on everything that I can, and you should too. So, back to the Sudoku problem. Yeah, so that was how I did the first one, and all that was is like a for loop for four, um, I'd say four row in input or whatever it was called, and then that cycled through, and then I put it through the checks, and I still need to finish the second part, so maybe I will do that for some of the episodes. But the thing is like each episode will only be like half of that problem, because it is a lot of coding, and I was kind of like explaining it as I went, so like it makes sense, because I could. And that was the problem with the code clashes, because I could just code all fast, and then like after the fact, oh, I was just swimming. Oh, anyway, I feel like that was, I don't know. Now I got the boat out. But basically, when I was doing the clashes of code, that was fun, and it was useful, and it was also blurry too. So that's why like live streaming isn't as appealing to me. Although I should turn this music down. I should, but I'm not going to. Hold on. It's not that bad for the sacrificing of going through the menu, and I don't think it blurs it, and like, I don't know. It's a bunch of hazard or randomness, but yeah. I was gonna say, usually it's not too loud for too long. Like now I can feel like I can. Anyways. So yeah, so a row is each list, and then checking if there's one and only one. And sorry, that was what I was saying. Is like I had it checked to see if there was one. Or actually no, because if the count equals one and the count of this one equals one and yeah. So, but it's gonna be. I don't think I actually like wrote it out in the code though. Or no. Because I was doing something like if the count equals one of each of the numbers. Anyways, I'd have to look at it. Now that I think about it, I was like, wait, that sounds like I just did do it. So I don't know where. Anyways. So that's what you have to do for part one. Part two is where you have to check every column. And this is where I started struggling, because for this, you kind of have to keep track of it every time. So you're looping through each list, and then you have to look at each number. And then you're keeping track of the index of that, so you can separate out as you're reading through each row. Each value needs to go into. I gotta. So like, and it's really zero-based indexes. So at index 0, 1, and 2, which is the first three of the first list, you need to put them in section 1, or I guess it'd be section 0 if you wanted to stay zero-based. But so the top left mini section. And so then you would have to do indices 3, 4, 5, right? Yeah, because 0, 1, 2, and then 3, 4, 5 are the middle top one, and then 3, 4, 5, 6, 7, 8. Yeah, because you want to end one less than the total amount, which is 9 units in there, because it's zero-based, so 0 counts as the first, the initial number. So anyways, and that's really one of the hardest things about learning computer science, is once you understand that it's zero-based and, just counting starts, like just subtract 1 from everything, like, but you can't just say that, because you need to understand why it is. Like, it's because it's so many spaces or addresses away from this address, because every memory spot in a computer has an address, like a mailing address for, the real world. And based on those addresses is how we can tell, well, first off, what bits are set, because the bits are set at each individual address. So there's actually an electrical charge or not an electrical charge in a series of 8 Yeah, okay, so that might have gotten a little too in depth and too wide, but the point is I don't even what was the point of all that? No, just kind of understanding like the indices and indexing. So, anyways, back to the Sudoku. So that's just row one. Then row two, you're dealing with the middle of the top left, the top middle, and the top right. And then row three, you're dealing with the bottom row of the top left section, the top middle section, and the top right section. So really the first three rows you have to read in, and then you can build the first three subsections of grids that you need to search. And see, that's even easier for me to code out and figure out than searching the columns. Because then it's like, you do need like 9 lists, and you build each list one at a time as so you're still doing all of this logic in one giant loop, right? And this loop is looping through each of the rows or each of the lists in the main list that's passed to you. So, and once you understand that, then it's really not that bad. And that's why it's an easier one. Now the blue one is the Sudoku solver. So that's where you have to start, whatever algorithm you choose. Because like when I'm doing regular Sudoku, like, oh, let's talk about that because maybe we can make a video of me figuring that out. I'm hesitant to say that because I feel like that could be like a 2 or 3 hour video. I mean, but let's talk through the logic. So, all right, so if you're going to solve Sudoku, well, so right there that's your solution verifier. So you need that code to run smoothly without any bugs or errors and test all the cases. And I mean all the cases too, because when I first did it and it was still a blue, I didn't test for the subgrids. I only tested for columns and rows. And I do Sudoku a lot. I love Sudoku. Like I've done multiple books of Sudoku, and and so that was a facepalm moment and a mortal moment. Like you think computer scientists aren't gods. They aren't anything special. We're smart, but I mean it's just 'cause, a lot of times it's because we're stubborn or really determined. Like a lot of outside factors, maybe a lot of pressure from family or whatever. But no, I mean, me, I'm just hard-headed with everything. So, but anyways, the fact is, yeah. Back to the Sudoku logic. Sorry, went off on a tyrant there. So if we're gonna, and it's about to get loud with the music. Oh, actually, yeah. Let's. Oh no. In between, after this video, where are we at? Oh, yeah. Well, I'm gonna go do that code video after this. So. I'm trying to think of how to put in words. Like, so when you're doing Sudoku, the first thing I look for is like, um, yeah, how do you explain that? I look at each subgrid and then, because this is really putting this into a user story or an even pseudocode, which is like half code, half English, and just kind of like a rough draft, if you will. So, to check, well, first thing I look for when I do a Sudoku puzzle is I look to see each little subgrid and then to see if there's, so I look for a number, like, anything, pick one, 2, 8, whatever, between 1 through 9. And I look at it and then I see the adjacent square next to it, like the adjacent subgrid, and see if there's the same number in that one. And if there is, then I check the third subgrid in a row. And mind you, this could be, or no, not diagonal. It could just be vertical or horizontal. Because you're thinking rows and columns, like doing the first 2 checks. And yeah, so since you're keying off of a specific number, you already know that that number exists in that subgrid. So you already know not to look for that number when you're doing that specific search. Or, yeah, you just basically pick a number. And so, oof, even then, so it would have to be, you'd have to do it by indices. So say you found a 5 in the very middle row of the very middle subgrid left. All right, so there's a 5 in the middle row. So is there a 5 in that top row, in the middle, the very middle subgrid, or is there a 5 in the bottom row? And if yes to either of those, then definitely go to look for the other one, and then okay. And so then once I find all of those, see this is already pretty cumbersome. Like thinking about the code that would have to power this, but basically. Yeah. So you would check to see if those, and then you check the columns. So, or wait, actually, no. That's only useful if one of them is a no, because you're looking for numbers that you can fill in. Sorry, that was my mistake. And even then, this is why it gets tricky, because as I'm doing that, it's almost at the same time, which it can't be, because everything is like sequential. I mean, or I don't know. That's a anyways, and even in computers, it is technically still sequential, even though different threads can run almost like, well, they can run simultaneously, but then, and we can also, even with a sequential and like a decent round robin system, or even like a decent scheduling system, sorry, not round robin necessarily, but, um, anyways, way digressing. Um, The Sudoku, though. So the other thing I look at is once I see that there's one missing out of the set of three for that number for a row of grids, basically is how I look at it. In this situation, like the example of the five and the very left one, I'm looking for fives in that row of subgrids. Now, then the next thing I do is I look for fives in the column of subgrids that's still in that same one. Like I'm looking at the top left subgrid and the bottom left subgrid for fives. And if there's only one more, but not two, then there's a chance that I could go look at that. And so say I do find one that has, or a situation where there's two in a subgrid row. See, now this is getting all complicated. Sorry, okay, no. So if we do find a situation where there's two of a number in a subgrid row or column, especially both, if it's both, and there's one subgrid that doesn't have that number, and yet every other one does. That's the easiest one, because that is like 100% verifiable. It is correct. That number is supposed to go there. So say there's a five in every subgrid except for the middle subgrid. Say in the very middle dot of this middle subgrid. Like say there's just Oh wait, sorry. Also, I had to realize that's why we left that, because yeah, our small pyre is like right over, well, way back there a little bit. We're gonna have to like go and erase that. Anyways, so that's a for sure guaranteed um, indication that a five is supposed to go there. Because if there's a five in every other subgrid except for that middle subgrid, then the rows, like I almost think of them as like lasers, or just lines, and then they go through, and if they intersect with another of the same number, then it's a no-go. You just can't put that number there. I guess that's the other thing, is like you could also do it. So talking about like that recursion way. Oh, see, look, we got a temple, but like that recursion way where you pretty much like brute force every combination. What I would do is I would start with eliminating what you can't do. So making a list of potential moves that aren't legitimate. Let's see. Ooh. I mean, I really have no cares for the sand if there's something better. All right, see right even there. Emeralds, it looks like. So, anyways, uh, oh yeah, and this one. Sorry, now I just like really don't want to. Oh, TNT. Yeah, I mean, I'll take it, 'cause I think I even have some already, right? Yeah. Um, but anyways, so if you know that a five can't be in a spot, then you might as well mark that, like, or either mark it or don't mark it, and only add other numbers to a list to try. So for potential solutions. And then, so the recursive way is just to try or have a list of attempted numbers for each piece of the grid and every subgrid that doesn't have a value already. And so, and even that, like, as I said, oh, shoot. I gotta be careful. Because if it falls, so say there was a piece of sand, a suspicious sand in the middle of that. And actually, you know what? I am gonna just demolish this whole thing. Like, I want to know, is there any other sand? I don't think so. That's a... Hey, let's get some light in here, too. Or actually, maybe light's not a good thing, because... Oh, never mind. That's very obvious. Alright. But anyways, yeah, so... And I don't even know... I haven't done a lot of the actual coding of stuff like that. Those types of algorithms that check every single, like, every permutation and combination. I've wanted to, and I have, like, started to, but yeah. So maybe this will be a fun thing. Because it will check to see, like, and that's why you need the Sudoku solution validator, and that still becomes a piece of your code when you're doing this new code to find a solver or make a solver. Yeah, I think this is. I'll see. Although, if. Even as I say that. Ooh. TNT. I mean, this is still gonna be fun. We could blow something up. But not grief anyone's stuff. I mean, that is just. Ugh, no. I'm not a fan. Like, I know it's entertaining, and I'm sure that would have been fun back in the day, but actually, no, I don't think my friends and I would troll each other like that. I mean, we would duke it out on GoldenEye, don't get me wrong. We would fight each other, or Unreal Championship. That was the best one, or Unreal Tournament. I think it was Unreal Tournament. Maybe there's both of them, I don't know. But that's the original gaming engine that like almost every game is based off of. It's funny. Diamonds, TNT. We need a sniffer egg. Can we get sniffer eggs from these? I mean, I'm almost inclined to say no, because we've gotten almost everything else, including... like, aggressive archaeology, destroying an entire temple just to find, like, a few pieces of broken pottery. Oh, that's horrible. Yeah, I don't know. That is like one way to do the solution solver, but I would prefer to do other things first. Like, it's easier for to wrap my brain around like an actual, like, try this one, try that one, and try to mimic the same way that I do, like the same logic. So I look for a number, say there's a 5, and I look for 5s in every other square, and then I start looking for or that's one way to look for things, and then another way is looking for what's missing. Like, start looking at subgrids and saying, okay, it's got all of these numbers, but it's missing a 2, a 3, and a 5. Oh, okay, so now this spot could be a 2, a 3, or a 5. And I have seen that written out when people... See, I don't write notes. I kind of keep that in my head. Just long enough until, like, I could look at another one, and then I, like, let it go. Like, okay, whatever, but I kind of remember it, but then I kind of, like, try to go focus on this other one. So, like, I intentionally, like, switch. Like, alright, now if there's... Oh, also... We need to be careful. I always get quiet when I do this because I'm worried about falling and blowing up, because I have done that. I forgot all about... I think I even knew, too. Or I think I knew that it was a possibility, but it had been so long since I'd seen... There we go. Disarm it before I even get down. And that's why I like preventative or preventative blue teaming. No, that's a hokey, like, roundabout way, like... Oh. Oh, and I don't need another emerald. Oh. Oh, okay. Sorry, that popped up. I thought that popped up. I was like, wait, no, Anyways. Take these. Yeah, I'll take the gold too. Whatever. I mean, I'm being really judgy on the sand. Because I already have a ton of glass, I think it's like... Oh, there's the alarm. Alright, well, that's actually pretty good. So I'll go ahead and do a video and just try to finish off the validation checker maybe, or something. Or maybe just do a bunch of white challenges. Because that's like, really for people just starting out with Python or any coding language. They need to have a bunch of the... Oops, that was a new one. Oh wait, first we'll go ahead and impaling and power. That's like good. We'll finish looting and then we'll call it good. But yeah, whenever you have 2, then you're like, you're confined to those 2. So I usually just like scrap that, or I mean, use the grinding stone and then like recycle the stuff. And then you have to build it up single ones. And granted, we have like 143 levels. But I digress. Let's keep looting. All right. So until next time, I think I'm gonna go do some coding and then, yeah, ta-ta. See you next time.